Hi, hello, welcome back. So today we are going to start with another interesting topic in light, that is mirror formula and magnification. So far we have dealt with important rules, ray diagrams, and in that we have seen the image position, nature and size of the image when objects are placed at different position. So there we have learned diagrammatically. Now here in this module, we are going to apply mathematical formula to calculate the position, nature and size of the image and as well as the position of the object. Let us discuss about some important symbols that we will be using in this chapter. So first one is object position. So object position is denoted by U. Then image position is denoted by V. Focal length is denoted by small letter F. So this is the symbol that we will be using. Now let's introduce the formula. The formula is 1 by F is equal to 1 by V plus 1 by U. This is the mirror formula. It is a formula connecting object distance, image distance and focal length. We don't have derivation for these formulas. You just have to remember this formula. Now let's start with magnification. So what comes to your mind when I say magnification? So we have already dealt with this topic when we do the ray diagrams, magnified image, right? So when I say magnifications, don't get confused that the image is bigger. So that is a misconception that most of the students have when I say magnification. They always come up with the answer that the image is magnified. No. So it means that, this term means that the size of the image compared to size of the object. So between C and F, where did you get the image? Beyond C. Then when it is placed beyond C, where did you get the image? Yes, between C and F. So there are 6 positions that we discussed in mirrors. So when object is placed at different position, you get the image position accordingly. So when we wrote the size of the image in that case, how did you write the image size? By comparing the size of the image with the object. That is what we call as magnification. Size of the image compared to size of the object. This is the meaning. It can be magnified, it can be diminished, or it can be same size. So what is the size of the image compared to the size of the object? That's what meant by magnification. That is the meaning of magnification. And if you asked definition, then we can define definition. What is the definition of magnification? Definition of magnification. So definition is, it is the ratio of image height to the object height, or you can say size of the image to size of the object. Ratio of size of the image to size of the object, that is also fine. Image height is denoted by the letter HI. Object height is denoted by the letter HO, or we say size of the image, size of the object. Now magnification is denoted by M. Now the formula is hi by ho. It is the ratio of size of the image to size of the object, or height of the image to height of the object. This is one formula. So this is the magnification formula in terms of height of the image and height of the object. Now if you want to write the formula in terms of image distance v and object distance u, then let's see how it is. So m is equal to minus v by u. This is in terms of image distance and object distance. So you don't have to worry about the derivation of these formulas. For grade 10 level we don't have any derivation for this. You just have to remember these two formulas for magnification and mirror formula, that is this one. Okay, yes, now let's proceed. So now we have two formulas for magnification, one in terms of height, another in terms of distance. Now let's combine both of them. So you can write hi by ho is equal to minus v by u. When you combine, you will get this. This is the combined formula. Now in our previous module we have discussed about sign convention, right? We have seen the sign conventions for real, virtual. Now let's see what will be the sign convention for magnifications. So magnification sign convention. So here when we talk about magnifications, it is the size of the image compared to the object. So we get real images as well as virtual images. Now let's see what will be the sign of magnification if image formed as real. So for real image, what is the sign? Let's see. So you can use any formula, either this or this formula to get the sign. So I think I'm using the first one. Okay, I'm using this formula to get the sign. So m is equal to hi by ho. Now real image means it is inverted. So what will be the sign of real image? If it is inverted, negative. Yes, so I am writing the height of the image hi, since it is real, the sign is negative. Now height of the object, what will be the sign? It is positive because it is above the principal axis. So minus divided by plus. So minus divided by plus is minus. So magnification is negative if the image formed is real. Now let's see what will be the sign of magnification if the image formed is virtual. So magnification for virtual image. Again I am using the same formula, m is equal to hi by ho. Now what will be the sign of hi? It is virtual image. So virtual image is formed above the principal axis. So sign will be plus. Now what will be the sign of object height? Yes, as usual, plus. So plus divided by plus is plus. So magnification sign is plus or positive if the image formed is virtual. So remember this is very important. If image formed is real, then magnification sign is negative, and if image formed is virtual, then magnification sign is positive. Now let's see some important cases. So case 1 is magnification minus 1. So here two things you have to keep in mind. One is the sign, other one is the magnitude. Magnitude means the value. Here I have written 1. Okay, so two things you have to remember. One is sign, second one is magnitude. Magnitude or value, whatever value that I am writing next to this sign. So the sign indicate the nature of the image, whether it is real or inverted. Then magnitude, the value indicate the size of the image. Size of the image, which means same size or enlarged or diminished. Understood? So two things you have to remember when I write magnification equal to minus 1 or magnification equal to plus 1 or magnification equal to plus 1 by 2 or minus 1 by 2 or plus 2. So the sign always indicates the nature of image and the magnitude always indicate the size of the image. Now here the sign is minus. So what is the nature if magnification is minus? Yes, if magnification is minus, it is real and inverted. Now what does the magnitude indicate? The size of the image. So here magnitude is 1. So magnification magnitude is 1. So what does it indicate? Any idea what does it indicate? Yes, we have the formula magnification equal to hi by ho, or magnification is equal to minus v by u. So if I use this formula, I'm writing the magnitude here 1. Our magnitude is 1 equal to hi by ho. Now I'm cross multiplying, so you will get ho is equal to hi. So what does this mean? Height of the image is equal to height of the object. So same size. Very good. Same size. So here magnification minus 1 indicates the image formed is real and inverted and of same size. Okay, now let's see case 2. Case 2, magnification is equal to plus 1. Now can you try? What does this sign indicate? Magnification plus. What does it indicate? Very good. Virtual and erect. And 1. Again value is 1. So wherever you see 1, it means that the image is same size. Same size. So magnification plus 1 indicates the image formed is virtual and erect and same size. Can you tell me which mirror gives you virtual and erect and same size? Very good. Plane mirror. It is plane mirror. Now let's move to case 3. Case 3 is magnification less than 1. What does it mean? Magnification less than 1. That means we have magnification formula hi by ho. So I am writing magnification less than 1. That means hi by ho is less than 1. Or hi is less than ho. Magnification less than 1 means image size is less than object size, which means that the image formed is diminished. So let's see some example. So less than 1, m is equal to, it can be minus 1 by 2, or I'm writing m is equal to plus 1 by 2. What does it mean? Magnification minus 1. What does it mean? It means that the image formed is real and inverted and it is diminished. So always remember, don't think that minus 1 by 2 which is less than 0. Don't think like that, because minus indicate, the sign indicates the nature. Wherever you see minus and plus, you have to quickly tell what is the nature of the image. And wherever you see the values or magnitude, you have to quickly tell what is the size. So here sign is minus. So what does it mean? Real and inverted. Here magnitude is 1 by 2, so which is less than 1. So what is the size of the image? Diminished. Now let's see the another example. Magnification plus 1 by 2. So plus, what does the sign indicate? Very good. Virtual and erect. Virtual and erect. Now value, it is 1 by 2. 1 by 2 is less than 1. So again diminished. Now let's see case 4. Magnification greater than 1. Again, so we have magnification equal to hi by ho. Magnification greater than 1, which means that hi by ho is greater than 1 or hi is greater than ho. What does this mean? Image size or image height is greater than object, which means that image formed is enlarged or magnified. greater than 1. Now let's see some example. M is equal to minus 2. What does the sign indicate? Real and inverted, because it is negative. So negative indicate real and inverted. 2 is greater than 1. Don't say minus 2. Okay, it is only 2 greater than 1. Minus is only for nature of the image. When I say the size of the image, you have to take only the number. Don't take minus 2. Okay, so 2 is greater than 1, so it is magnified. So these are the 4 important cases that you should remember. So thorough with all the formulas and the cases. If you have any doubts, don't hesitate to post it on the comment box. I'm always here to help you. Thank you.